All right, everyone, let me figure out how to make this big. There, I got it. Okay, so in this lesson, you guys are going to be, we're going to be going through factoring. So ideally, as we're going through this, a lot of this should seem very familiar and should be review. So just evaluate where you are and what amount or level of practice you need, because factoring is something that we want to be very fluent with. So let's start off and figure out what is factoring. So I know this isn't a great definition, sorry. Factoring is the process of finding the factors, right? So finding what multiplies together to get an expression, right? So you're breaking something into parts, to pieces, and like the smallest pieces where it can't be broken up anymore. It's like splitting an expression into a multiplication of simpler expressions. So hopefully you remember way back, maybe, I don't know, was this fourth grade, third grade? First grade, I don't remember when exactly you learned this, but somewhere in elementary school, you learned about fact families and prime factorization. Okay, so for instance, if you're given the number 48, I can break this up into, right, like fact families. Oh, 48, that's 12 times 4. This is 3 times 4. This is 2 times 2. This is 2 times 2. So the prime factorization of 48 would be 3 times 2 times 2 times 2 times 2. I don't know why I switched my 2's in the middle. Right? So you're really looking at like, when could you not break it down anymore? If you multiplied these out, I would get 48. This is prime factorization. I actually have a bunch of prime numbers that I'm multiplying together and I can't break it down anymore. Like, it is impossible. And I'm not going to sit there and do 2 times 1. I could do that a million times. It's prime. So that's prime factorization, and that's an important piece to know. So if we had 15, what's the prime factorization of 15? Oh, 3 times 5. Can't break it down anymore. What's the prime factorization of 29? Well, 29 is prime. So like, this is already prime. I cannot break this down anymore. I'm not going to do 29 times 1. That's silly. It's not factoring. I'm not making it any smaller or simpler. Okay, so what if you were trying to do the prime factorization of x to the 5th? Well, I would write this out as x times x times x times x times x. That's what x to the 5th means. What if we were doing x to the 6th times y squared times z? That would be 1, 2, 3, 4, 5, 6 times y times z. That's what it means. I'm like breaking it apart into its smallest pieces. What about 3x squared plus 3x? Right? This is the same thing as saying 3 times x plus 3 times x. But I haven't broken it down. I have this addition sign in here. And it's things that are multiplied together. I didn't do that. So I want to figure out, what do these have in common, and I want to factor it out. So they both have a 3x, and if I pull that out, I would be left with x plus 1. Right, and so this would be the prime factorization. I can't break these down anymore to 3x squared plus 3x. So what if you had something like x squared plus 8x minus 9? Maybe you know how to factor it, and that's great. You can do that if you would like. But this is what we know as a trinomial. There's 3 terms. This factors into 2 binomials if it factors at all. And you might know the answer to that question for this specific one right now, but it might not factor. You could have a trinomial that does not factor, and that would be called prime. It is possible that you can't break it down anymore. Before we actually factor, let's take a look at this. X minus 9 plus x plus times x plus 1. This is an example of 2 binomials, right? This is what I would want to break this up into. Actually, this is not the actual factored form of it, right? It's not. They're similar, but they're not. This is not factored form of it, so don't have that misconception there. So these are 2 binomials. How do we multiply them? We're going to multiply them using double distribution. Right? Double to distribute, we know what that means. Right? So you might remember the acronym FOIL, but this is an acronym. is a way to remember how to do double distribution. You are not foiling. This is not a verb, right? It can't be used as a verb. It's not an action that I'm doing. It is a way to remember how to do double distribution. You can distribute, that's a verb. So just be careful with that. So some of you guys might remember a box method. That's great, but we're going to try to move away from this. Like that's not something we want to see on everyone's paper as we're doing this. Like we want to be able to use double distribution to multiply this out, to expand this. Okay, so when I'm saying double distribution, we're going to distribute the x, and we're going to distribute the -9. When I do that, I'm going to get x squared plus x minus 9x minus 9. Right? And so maybe this rings a bell that I then would need to combine the two middle terms to simplify this. 1x minus 9x gives me -8x minus 9. Right? And so this is the trinomial that this multiplies out into. If I were to do some factoring, I would get that. So I need to be able to figure out, how do I break this apart to get this? Where is that -9 and that 1 coming from? Maybe you know. Right, so just like any other operation, we need to go in reverse to decompose this or to factor this. Right, so if I was going to grab a new color and go backwards through this, I first of all need to figure out where is this. I need to do this step, right? I need to figure out, how do I get from here to here? Okay, so I would need to, that -1 and that, I'm sorry, it's a +1, that 1 and that -9. Well, those are two numbers that multiply out to -9, and when I add them, I get -8. Right, so if you remember, you have ax squared plus bx plus c. They multiply to c, and they add to b. Multiply to c, they add to b. Okay, and then I'm going to break this apart. So then I've got x squared. I'm not going to do anything crazy. I'm just literally just going to break this apart. X squared, in no particular order, plus x minus 9x minus 9. You know what? In fact, I think I'm going to show you the other way so that you don't necessarily think that the order matters. X squared, let's say I wrote minus 9x plus x minus 9. So I basically have this. I just wrote the two middle terms in a different order. But you can add and subtract in either order. You can add in either order, I guess is what I should be saying. So now what I'm going to do is I need to like undistribute. That's not really a word, that's factoring. So I'm going to group the first two and group the last two, and I'm going to factor out what's common. So what's common between x squared and -9x? Well, I can factor out an x. They both have an x to give. When I do that, I'll be left with x minus 9. These two, I can't factor. That's prime. So all I can pull out really is a 1, and I'd be left with x minus 9. So now you might have some recollection of this about maybe what your teacher told you or something, but basically I have two numbers that I'm adding together. They both have an x minus 9, so I'm going to factor out an x minus 9. When I do that, I'm left with x plus 1. And there, I've now factored this trinomial. I've gotten back to the starting point. Okay? You can kind of see I'm distributing, right? I was going to do x times x minus 9. I'm doing x times this. And then I'm doing 1 times this whole thing, right? This is one number. It's like you're distributing each one of those in. Double distribution. And then you're breaking it apart. Okay? So there's a lot of different types of factoring. So there's greatest common factor, which we kind of just alluded to, GCF. Factoring by grouping. I just did it. I grouped two and I factored out what was common. General trinomials. That's when you've got ax squared plus bx plus c. A will not always be 1. In the example we just looked at, a was 1. Perfect square trinomials. Difference of squares, and then sum and difference of cubes. So these are the ones that we're going to focus on now. And that we want to master and practice now. There are things that you've worked with in the past, and so this is a review. Sum and difference of cubes, not you may have had exposure to it, but this is going to happen a little bit later in IAF. It's going to happen second semester when we learn when we learn about polynomials. Okay, or like higher order polynomials. So I wanted to put this one up here because it is still factoring, but that's not something that you need to worry about right now unless it interests you to look up and you already know all of these other 5 ones. So we're going to go through some examples of each one of these and then kind of close out with some practice before you complete the assignment. So greatest common factor. So I'm looking for the greatest common factor that I can factor out that both of these are divisible by. That's really what greatest common factor, or GCF, is. If you don't find the GCF and you have to do it in pieces, that's fine. But if you can find the GCF right away, you're going to have it completely factor. So let's focus on the 90 and the 27. They're both divisible by 9, and that's the largest number that they're both divisible by. So I'm going to actually just do this. If I then look at the a's, a to the 9th and a squared. Well, all I can pull out from that is an a squared. I can't do anything larger than an a squared because this doesn't have any more to give. B, I can't factor out. So let's see what happens when I do this. So I'm factoring it out in front. 90 divided by 9, I've got 10. A to the 7th, right? I had 9, 2, 3, 4, 5, 6, 7, 8, 9, and I got rid of 2. So 1, 2 are going to cancel, and therefore I'm left with 7, right? And then plus 3, the A's are gone, they're canceling, B to the 3rd. So I can then take a look at my answer after I've factored out the greatest common factor. And this has nothing else to get. 10 and 3, they don't have a common factor. A to the 7th and B cubed don't have a common factor. I should be able to distribute what I factored out back in and get what I started with. Great way to check your work. What about number 2 right here? So 20 and 24 are both divisible by 4. I believe is the greatest common factor. And then what about x? I can divide by x, and I can divide by y on both of them. So 4xy is my GCF. So I'd be left with 5x, y to the 3rd, and then minus 6, and that's it, right? There's no x and y left, they're gone. So that's my factored form of this expression that I'm given. So then let's take a look at factoring by grouping. So here, 12a to the 3rd minus 9a squared plus 4a minus 3. I'm going to go ahead and factor this by grouping. And so what I mean is I'm going to group the first 2, group the last 2, and then factor out what's common. So GCF still comes into this, right? But this is what is known as factoring by grouping. So then I want to find the GCF between 12a to the 3rd and negative 9a squared. They're both divisible by 3 and a squared. When I do that, 3a squared and 3a squared, I'm left with 4a minus 3, which is good. That's what I want to be left with. Okay, what can I factor out of these? Nothing. A 1, and I'm left with 4a minus 3. Right? So the goal is that we want the same thing in here. And I think I already said this, but I'm kind of losing it already. I remember learning this in high school, and I just knew that we had to have the same thing. But I didn't really know why. Right? I was just like, oh, this is just, then you do that, and that's one of your factors, and then what's on the outside is your other factor. But the real reason behind it, and I'm going to say this, and it might not click for all of you, but if I get 1 or 2, I'll take it. So what's happening here is that these are just 2 numbers being added together, and they actually have a common factor, and that common factor is 4a minus 3. Like, we want to express them in a way that they have a common factor. When you factor out 4a minus 3, or divide them both by 4a minus 3, I can then ignore this, and I'm left with 3a squared plus 1. That's why you want them to be the same, so that you can finish factoring. If they're not the same, you can't factor anymore. Like, you're done. There's nothing to factor out. They need a common factor in those 2 numbers, or those 2 terms. So this would actually be factored form of this polynomial, this expression that we started with. I can't factor it anymore. Those are prime factors. What about this one? So let's do the same thing. Let's group the first 2, group the last 2, and factor out what's common. What's common between 40 and 30? 10. I can factor out a 10x. If I do that, I'm going to be left with 4y, right? And then plus 3. Okay. So what can you factor out of negative 100y minus 75? I think minus 25 is my first thought. If I divide by negative 25, divide by negative 25, I'm going to be left with 3y. Nope, 4y. I got overconfident. What did I just say? 4y plus 3. Perfect. So just like we said before, you've got the same number right in here. So I'm going to go ahead and factor that out. So I'm going to factor out 4y plus 3. When I do that, and I divide both of them by it, I'm going to be left with 10x minus 25. Are we done? Nope. I'm going to look at my answer and realize that I have not factored this completely. This term right here factors more, right? 10 and 25 have a common factor. What do 10 and 25 have in common? Well, I can divide them both by 5, right? So I'm going to factor out a 5, and then I've got 4y plus 3 and 2x minus 5. Now, I can't hear any of your questions, obviously, but I would guess that is one of your questions maybe, why was I able to write the 5 over here? Right? And really, I could have written this a number of ways. I could have said 4y plus 3 times 2x minus 5 times 5. Right? I could have written 5 times 2x minus 5 times 4y plus 3. I could have written 4y plus 3 times 5 times 2x minus 5. Right? Multiplication is commutative. Like, I am able to switch the order in which you multiply. All three of these are just being multiplied together. The parentheses indicate to me what I need to do first. So it doesn't matter what order I choose to do it in. This 5 is only going to be distributed into one. Like, I'm not going to distribute it into everything. Me giving it to the 4 and the 3 would be fine. It would be fine. There'd be absolutely nothing wrong with this. In fact, I could have factored out the 5 right away. I could have recognized that all 4 of these terms have a common factor, divided them all by 5 and pulled it out front, and then went ahead and continued with my factoring by grouping, and that would have been fine. So that order is completely fine. Multiplication is commutative. Okay, so these would be my prime factorizations. Typically, the 5 is written out front, and that's why I chose to do that. It's a little silly to write it at the end or like shove it in the middle, but technically it's not wrong. Okay, so that was factoring by grouping. We did GCF, which as you're seeing, like there's like a lot of things that are connected in there. And then let's just look at some general trinomials. So kind of like the one we started with, but here my A value is 10. Right, so we said that idea, so we've got a general trinomial is ax squared plus bx plus c. We like when A is 1, like me included, that's why I'm saying we, because it becomes a lot simpler. Right? And so there's a few different ways to do this. You can do this using the AC method. I don't know if that's really an official term. There is a box method, and I'm going to write that down as a method because we don't want to be doing that anymore. We want to move away from that. And we have guess and check. And guess and check is more logic based. Ideally, if you want a more algebraic way where it's going to work every single time, go ahead and use the AC method. This is where we want to ultimately be, all of us, not just a few of us, all of us. Okay, we want to be in this guess and check because this is the one that's going to be quickest for us. And why it's so important to be a quick is that we're not, right now we're just factoring, right? We're just learning the basis of this or practicing the basis of this, but this is going to be intertwined to other topics as you grow and become, and as we go into other learning, whether it's an AAF or classes beyond this, and you want to recognize that, oh, I need to factor this, and it's not, my goal might not be to factor it, but I need to factor in order to successfully be able to solve something. And so that's why guess and check is going to ideally be quick for us. So I really encourage you to try that out and work towards that and set that as your goal. Okay, so For the AC method, what I'm saying is I have to multiply A times C, and that would give me 10, and then I'm going to find two numbers that multiply to 10 and add to negative 11. Okay, so I know I've got to have 10 and 1. They both have to be negatives. Then I can break this apart. 10x squared minus 10x minus 1x plus 1, right? So I broke this one apart. I'm going to group and factor out what's common. So in these first two, I can factor out a 10x, and I'd be left with x minus 1. In these second two, I can factor out a negative 1, and I'd also be left with x minus 1, right? And then they both have an x minus 1. So I'd be left with, when I factor that out, I'd be left with 10x minus 1, and that would be factored form. Okay, so that's what I'm going to refer to as the AC method. If we're going to guess and check, we can think logically through this. Well, two things to multiply to 10x squared. I could go with 10x and x. Two things that multiply to 1. Let's say I put 1 here and 1 here, and I was like, okay, they need to add to negative 11 and multiply to a positive. They both got to be negative, right? And so I can just get there without ever having to show that step, like just thinking through it. Okay. And your guess and check, what I'm saying is, okay, we know when you're guessing, you know A and C are going to work because you're looking at the first and the last. Remember that acronym FOIL. So then we just need to check the outer and the inner. So that's the checking part. You guess using F and L, first and last. You check using O and I. So I'm going to do guess and check for this one right here. Okay. So I might not get it right away. I actually don't know the answer. So 4 and negative 10 is what my focus is going to be on. So let's say I did 4x and x. And then negative 10, let's say I need it to be 39. So 5 and 2 isn't going to do it because I would have a 20 and a 2. You know what? Maybe it's not a 4. Maybe I needed to do 2 and 2. So maybe this is 2 and this is 2. 10, then I would have 10. You know what? It was probably 4. Right? So this is what? I'm just thinking logically through it. This is 4 and this is just 1. And then that negative 10, I've got to have a negative 10 here because that would give me negative 40 plus 1. So then if I multiply this out, I've got 4x squared minus 40x plus x minus 10. Negative 40 plus 1 gives me negative 39. Therefore, this is factored form. So what about this one? Okay, I'm going to make this simpler for myself before I even dive into it. 40, 44, negative 24. I can actually factor out 4. That's a 4, I promise. I'll erase it and fix it. So I'm left with 10x squared plus 11x minus 6. Don't forget the 4. And then I'm going to figure out what these have to be using guess and check. So let's see. Let's say I did 5 and 2. So if I had something like 15 and 4, that works, right? So this could be a 3 and this could be a 2. One of them's got to be positive, one of them's got to be negative, right? This would give me 15 and 4, which would somehow give me 11. I want to subtract the 4, and I want the 15 to be positive for this to work. Woohoo! Again, if you want to use the AC method, do that, but I really want you to build your understanding of this idea of guess and check. It's where we want to ultimately be. Again, if you have these written in a different order, nothing wrong with that, as long as you have those 3 as your factors. What about perfect square trinomials? What's a perfect square? 25 is a perfect square, right? That's 5 times 5, or 5 squared. 9 is a perfect square. That's 3 times 3, which is 3 squared. Right, so these are what I mean by perfect squares. I'm not getting anything, I'm not getting some crazy decimal. They're not irrational. They're perfect squares. So 9x squared plus 6x plus 1. If I use guess and check, 9, I've got 3x and 3x. To get 1, I've got to do 1 and 1. So you've got 3 plus 3, so they're both positive. Oh, check that out. They're the same. So I should be expressing this as 3x plus 1 quantity squared. What about this one? Right? You might be able to, you can kind of see what's happening here. Oh, this is a perfect square. That's 5x. This is a perfect square. That's 2. If I multiply them together, I get 10. 10 and 10 is 20. 3x. 1. 3 times 1 is 3. 3 plus 3 is 6, right? So being able to recognize that just might make your life a little bit easier. So here I'm going to get 5x plus 2 squared. These are things that help with fluency. We've also got difference of squares. 4x squared minus 25. So let's say you didn't know difference of squares yet. What this really means is I've got this. And if I go ahead and I did guess and check, I'm going to have, let's see, 2x and 2x. 25, the only thing I can really do there is 5 and 5. To get 0, one of them's got to be plus, one of them's got to be minus to get that 0 in the middle, right? So I'd have negative 10x plus 10x, which would give me 0. Oh, look at that. I've got difference of squares. Immediately, and this is the same idea when you're dealing with complex conjugates, right? So I've now got this breaks apart into the square root of this, right? 2x plus 5 plus the square root of this, and then minus the square root of this. Sorry. These are conjugates. Right? They're conjugates, and that's what's making that middle term cancel. So even if you then solve something like 2x minus, no, I wouldn't have that, 7 times 2x plus 7, knowing that, okay, they're conjugates, so I'm not going to have a middle term, so it's just going to be 4x squared minus 49. Right? It's a little different. You guys dealt with it with a plus bi times a minus bi, and we talked about how it was a squared plus b squared, just because of the way because I squared is -1, you end up with a plus here, whereas you end up with a minus here. So be mindful that it's a little different. Okay, so using this method, this is going to factor into 3x minus 1 times 3x plus 1. Look for things like this. That's the goal. We want to look for them. You try. If you haven't paused and tried any of these, try these 4. What did you get for number 12? Maybe, did you write down that it's prime? I hope so. I tried to trick you on this one, to be honest. Right? There is no sum of squares. Right? So this is going to link to where we're going. If you tried to graph y equals x squared plus 16, like when we're factoring these, we really are going a step. There's nothing to solve, right? They're expressions. But you're really going partway through the process of solving. Like factoring is like on that road to solving. It's not equal to anything, so there's nothing to solve for, but if I set it equal to something. So let's say we made this into a graph. If you were to graph x squared plus 16, the entire thing is going to happen above the x-axis. Terrible graph. And there's going to be no x-intercepts because it's prime. It doesn't have an x-intercept. It has no solutions. This doesn't factor anymore. Okay? What about this one? Did you think about factoring out a common factor? 4x squared, and I'd be left with x squared minus 1. Hopefully you didn't stop there and you notice that this is difference of squares. So you've got 4x squared times x plus 1, x minus 1. And that is the prime factorization of this. Please don't break this apart more. I know that's x times x, but please just leave it. What about this one? Okay, so 10 is the same thing as 5 times 2. If I make them both negative, I'll get myself to -7. So that's x minus 5 times x minus 2. I can check it too. X squared minus 2 minus 5, and then positive 10. Ooh, tricky. You know what? I think I'm going to go over here and just call t x minus 1 and come back to that. So this is t squared minus 10x. Oh, why did I write x? I just called it t. Plus 25. Let's factor that. That's going to be t5. T, it's got to be minus 5 t minus 5, right? T squared minus 5 gives you negative 10, 25. So that's a perfect square. So you've got t minus 5 squared. And let's go ahead and plug in that x. X minus 1 minus 5 squared. So that's just x minus 6 squared. Right? I'm actually curious if anyone multiplied this out. Like, you could have done that, right? I could have sat here and said, okay, so this is x squared minus 2x plus 1 minus 10x plus 10 plus 25, and then combined like terms, and I would have had x squared minus 12x 1 and 11 plus 36, and then I could have just factored that, and I would have gotten x minus 6 squared. That's fine too. Just another way to think about it. Amazing. So now what do you do? So now your job is to complete the Go formative, which is graded on accuracy. Some of it self-grades, as we've said in the past, like you might need to be patient with some of it. So just make sure you're going back and checking it. My encouragement, and hopefully you're not watching this video until later on into break, is that you give yourself like a brain break. I wouldn't worry about this right at the beginning, that you want this to be something that's fresh in your mind when we're returning. So if you're watching the video now, maybe hold off on doing the work until later. Or make sure that you're coming back and doing some of the supplemental resources before we come back to school after break. It's okay to take a break, over break. So some of it self-grades, some of it doesn't. It is graded on accuracy, and some of it is just if you put it in a weird form. You might just need to be patient for your teacher to go back and look at it. So my other suggestion is to really use the resources to practice factoring. There's a lot of resources there, and how you get good at factoring is practice. That's how you build fluency and speed with it, and you're able to work up to those more rigorous problems. Like if you're doing more of them, you're going to recognize it when it comes up and when it's built into other things. So our goal is to be fluent and quick with factoring. I don't know if you guys are too young for this, but I remember doing like mad minutes in elementary school. And I know some of it seems silly, like why should you be able to work so quickly through it? And it's not that you need to be able to do it under a time restriction. It's that we want you to be fluent with it. And sometimes putting in that time restriction helps build that fluency, and it forces you to build that fluency. So this takes a lot of repeated practice to gain confidence. So not just 3 problems, 4 problems, like just keep practicing and just make a habit to practice and practice regularly so that you gain confidence and it's fresh in your mind. So other than that, we will see you all soon in 2021, kind of see you. And yeah, so have a great break, and we will see you guys soon. Thanks everyone for watching.